everybody, I'm Miss Cooksey, and today we're going to be talking about the power rules. So the power rules are going to be rules for exponents when we are raising a power to another power. So there's three different rules we're going to talk about today. The first is power to a power, then power of a product, and power of a quotient. You'll notice that all of these rules really connect. It's really one rule that we're applying in three different places, but they do have different names, so I'm going to introduce them separately. The first rule we'll talk about is power of a power. So this means I have a to the m raised to the n power. I have an exponent raised to another exponent. When this happens, we are going to multiply our exponents. So a to the m times n. Let's see what this looks like in practice. Y to the fifth squared is y to the 10th because 5 times 2 is 10. X to the third is x to the ninth. X to the 2 to the fifth times x to the third. This one's a little tricky. So the first thing we're going to do is this power to a power. So x to the 2 to the fifth is x to the 10th. Then we're multiplying x to the third. Well, we learned in the previous video that when we are multiplying exponents with the same base, we add the exponents. So x to the 10 plus x to the 3 is x to the 13. The last one's a little bit similar. N to the 3 to the 2 is n to the 6th. N to the 4 to the 3 is n to the 12th. N to the 6th times n to the 12th is equal to n to the 18. So these rules all build on each other. Every rule we learn will continue to apply as we learn new rules. Next, we have power of a product. So this means we have a product like a times b, and we're raising that to a power. Well, this rule works exactly like the distributive property. When we have an exponent outside of parentheses, we're going to apply the exponent to both of the terms inside. So a times b to the m power is the same as a to the m times b to the m. Let's look at that with some examples. 3a squared b to the fifth c to the third power means I'm going to apply that third power to every single piece of the term in the parentheses. So I will start with 3 to the third power. 3 times 3 times 3 is 27. A squared to the third power, we're going to use our power of a power rule. A squared to the third power is a to the 6th because 2 times 3 is 6. B to the 5th to the third power is b to the 15, and c to the third power is c to the 3. Next, we're going to evaluate negative 4xy to the third times negative 2x squared to the third. In this example, we are going to do power of a product to each individual expression, and then we'll multiply the expressions together. So negative 4 to the third power is negative 64. X to the third power is x to the 3. Y to the third power is y to the 3. Then we have negative 2x squared to the 3. Negative 2 to the third power is negative 8. X squared to the third power is x to the 6th. At this point, we're going to multiply everything together. So negative 64 times negative 8 is 512. X to the third power times x to the 6th. Remember, when we're multiplying exponents with the same base, we add the exponents. So that's x to the 9th, and then y to the 3rd. Next example, we have negative 3m squared into the 4th to the 3rd power times 2 into the 5th power to the 4th power. Again, we're going to evaluate each individual expression, then we will multiply the two expressions together. So negative 3 to the 3rd power is negative 27. M squared to the 3rd power is m to the 6th. N to the 4th to the 3rd power is n to the 12th. 2 to the 4th power is 16. N to the 5th to the 4th power is n to the 20th. Now we're going to multiply our two expressions together. So we're going to start with negative 27 times 16, which is negative 432. M to the 6th doesn't multiply to anything, so m to the 6th. N to the 12th times n to the 20th is n to the 32nd. The last rule we'll look at is power of a quotient. This rule is going to look very similar to power of a product when we are dividing terms and the division is being raised to a power. We are again going to distribute that power to both terms, the one in the numerator and the one in the denominator. So here we have 4x squared over 5. I'm going to square every single thing in these parentheses. Excuse the second parenthesis, that was a typo. So 4 squared is 16. X squared is x squared. 5 squared is 25. 16 x squared over 25. Then I have 3x squared over y over x over y. Well, I'm going to raise every single thing here to the fourth power. So 3 to the fourth power is 81. X squared to the fourth power is x to the eighth. Y to the fourth power is y to the fourth over x to the fourth, y to the fourth. I raised every single piece of this expression to the fourth power. Now I'm going to use my division property of exponents to simplify even more. So x to the eighth over x to the fourth. When we divide exponents with the same base, we subtract the exponents. So 8 minus 4 is 4. So that leaves me with 81 x to the fourth. Y to the fourth over y to the fourth. 4 minus 4 is 0, and anything to the 0 power is 1. So we don't even need to write the y. We're left with 81 x to the fourth. In this video, we learned about our power of a power rule. So if a power is raised to another power, we multiply those exponents. We also learned that if there is a exponent on the outside of a product or a quotient, on the outside of parentheses where something's being multiplied inside or something's being divided inside, we will apply that exponent to all of the parts of the expression on the inside of the parentheses. Now, remember, this only works for products and quotients. If something inside the parentheses is being added or subtracted, there is a different rule that we need to use. And we'll talk about that in a future video. Thanks for watching. I hope this video is helpful. Make sure you subscribe so you never miss a video, and I'll see you next time.